The next question is a power series. So we're supposed to find the center, the radius of convergence, and the interval of convergence of this power series, right? So let's do it. The common term of this series, so an is 3x minus 2 raised to the power n divided by n squared. So let us apply the root test. So nth root of absolute value of an is going to be absolute value of 3x minus 2 divided by n raised to the power 2 over n. Right, and we know from the lectures that n raised to the power 1 over n goes to 1 as n goes to infinity. So here it is squared, right? So which is still 1. So the limit of this thing is just absolute value of 3x minus 2. So which means that our series diverges if absolute value of 3x minus 2 is bigger than 1, and converges absolutely if absolute value of 3x minus 2 is less than 1. Right, so the interval of convergence is the set of values of x for which the absolute value of 3x minus 2 is less than 1. Well, I guess it's probably more convenient to kind of write it explicitly, so let me just rewrite it. So let me just solve this inequality. So if the absolute value of something is less than, well, than 1, then that something is between negative 1 and 1, right? So minus 1 is less than 3x minus 2 is less than 1. So I guess in order to, so we want to really estimate x itself. So we will divide this by 3. So minus 1/3 is less than or equal than x minus 2/3 is less than or equal than 1/3. And in order to find the conditions for x, I'm going to just add plus 2/3. So doing that, I will get 1/3 less than x less than 1/3 plus 2/3 is 1. Right? So this is the interval of convergence. Well, no, sorry, this is we don't know yet whether it converges when x is exactly 1/3 or exactly 1, right? So we know that for these values of x it does converge, and for values of x that are bigger than 1 or smaller than 1/3 it diverges, right? But also we know that whatever is in the middle, so which is 2/3, is the center of convergence, and this 1/3 is the radius of convergence. So this is the radius, and this is the center of the interval of convergence. 2/3. So the center is 2/3, the radius is 1/3. So the remaining part of the question is to figure out whether it converges at the endpoints, right? So what if x is 1/3 or x equals 1, right? So for these values of x, the absolute value of 3x minus 2 is going to be exactly 1. And our series is going to be, well, for one of them is going to be negative 1 to the n over n squared. For the, I guess, this is when x is 1/3. And when x is 1, we are going to get the sum of 1 divided by n squared from 1 to infinity. From 1 to infinity. In either case, the series converges absolutely because it is a p series where p is equals to 2. So which means that our series converges at the endpoints of the interval of convergence, and the interval of convergence is from 1/3 to 1, including the endpoints.